Hello everyone, it's me Anjana from LearnoHub, the free learning platform where you can study Math, Science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 4 Linear Inequation. We have already discussed the main concepts in our previous lecture. If you haven't watched that video, do watch it. Today we will be discussing the representation of linear inequations, solutions on number line and also the comparing of inequations. We'll understand the concepts and solve more problems from exercise 4B. Are you all ready? Let's start. Yes. By now we know how to solve linear inequation. Let's see how to represent these linear inequations on a real number line. This is how we have a number line. A straight line with points 0, 1, 2, 3, 4, 5, 6 and an arrow mark. This arrow mark means it is extending to the positive infinity. Here negative side minus 1, minus 2, minus 3, minus 4, minus 5 extending to the negative infinity. This is a representation of a real number line. Okay, if I need to mark some points, let us take minus 1, 0, 1 on this number line. We have to find these points first. First, minus 1. Here we have minus 1. Mark this point. Then 0. Here we have 0, 1. Here we have 1. Okay. This form of representation of a set is called the roster form. Roster form. Okay. It is given in the roster form. Within the brackets, the elements are given. Then we just need to mark the points on the real number line. Okay. Now, in case it is given like x such that x belongs to R and x greater than or equal to 2. Okay, this form of representation is called set builder form. Set builder form. Okay, to represent on the number line, either it will be given like this or in this way. Here, only the replacement set and the inequality conditions are given. We need to first find what the elements are. The elements cannot be represented within flower brackets in this case. We cannot exactly represent the elements when it is given in a set builder form. If you take x greater than or equal to 2 and the replacement set is real numbers, there are many points, right? Here we have only 3 points, so we could represent it within flower brackets. When there are many points, we cannot put them inside a flower bracket. In that case, we will be giving the conditions only. Okay, we will be studying how to represent integer values, whole number values or real numbers with inequations on the real number line. We have studied 4 inequalities. Less than, greater than, less than or equal to, greater than, equal to. Here, this 2, that is less than and greater than are called strict inequalities. Okay, less than or equal to, greater than or equal to are called non-strict inequalities. Non-strict inequalities. This means if we are given x less than 2, here the value of x should be less than 2. 2 cannot be included. The value of x cannot be 2. Or x greater than 2. This means the value of x should be greater than 2. 2 not included. Okay. The point is not included in case of strict inequalities, less than and greater than. When it comes to non-strict inequalities, x less than or equal to 2. This means the value of x can be 2 or values that is less than 2. X greater than or equal to 2. The value of x can be 2 or greater than 2. Understood? These are strict inequalities and non-strict inequalities. To represent them on a number line, to represent strict inequalities, we will be using hollow circles. Okay? And to represent non-strict inequalities, we will use darkened circle. This is how we represent the darkened circle. Okay, when the point is included, we have to darken the circle. For strict inequalities, we will be using the hollow circle, and for non-strict inequalities, the darkened circle. These are also called open circle, and this is a closed circle. Okay, when point is included, we are using a closed circle. Hollow circle indicates strict inequality. Number is not included in the solution set. Darkened circle indicates range involving equality as well. Equal to sign means the point is also included. Number is also included in the solution set. For example, now let us take the case of real numbers. X belongs to real numbers and x greater than 2. Okay, here again x is greater than 2 is the inequality that we are taking, and now the x is belonging to the set of real numbers. First, draw a real number line, mark points 0, 1, 2, 3, 4, 5, 6, 7. Minus 1, minus 2, minus 3, minus 4. Find the point 2. Here we are using a strict inequality, which means the point should not be included. That is, we will be using a hollow circle. Find the point 2, use a hollow circle here. This means 2 is not included. Any values of x greater than 2. Here 3, 4, 5, 6, etc. are greater than 2. But we cannot mark hollow circles in this case because these points should be included. Neither darkened circle can be used because here when you see this, between 2 and 3 we have many points. You have 2.5, 2.1, 2.11, etc. comes here. All these points should be included. In that case, we will be using a line. This is how we can represent the solution set, extending to the positive infinity. When you use this line, all these points are included. You cannot mark 3, 4, 5, 6 because they are integer values. We need real numbers. Between 2 and 3, we have many real numbers, fractions, decimals, etc. are there within this. All these should be included so that we are using the straight line. Clear? This means all the points are included. Here, we have used a hollow circle because this is a strict inequality. If it was x greater than or equal to 2, then what difference comes? We have to use the darkened circle. We have to include 2 here. In that case, we will darken the circle. Got it? This is how we can represent a non-strict inequality or an inequality that is greater than or equal to. If it is less than or equal to, extending towards this direction. Understood? Now let us see how to represent these inequalities on a real number line. Here we will take a number line. We have to represent x such that x belongs to R and x less than 3. Here we will mark 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Okay, we have to find the point 3 first. Here we have 3. Now, to use the hollow circle or the darkened circle, which one should be used? Here, x less than 3. Less than is a strict inequality. In case of strict inequality, the point will not be included. Here, 3 is not included. Every values of x less than 3. Here we have 3. This is 3. Put a hollow circle here. And any point that is less than 3 comes here. Okay. Up to the negative infinity. It is extending to negative infinity. Now, the second one, x such that x belongs to R and x greater than 3. Okay. We'll draw a real number line. Mark points 0, 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Here we have to find the number 3 first. This is 3. This is again a strict inequality. Greater than and less than are the strict inequalities. Here we mark the 3 and any point that is greater than 3. Any value of x greater than 3. Greater than 3. Here, this is where we get the graph. Okay. Darken this up to the positive infinity. Got it? Up to positive infinity. This is how we can represent the greater than and less than inequalities on the real number line. Okay. These are the strict inequalities. In case of strict inequalities, we will be using the hollow circle or the open circle. Okay, next let us represent x such that x belongs to R and x less than or equal to 3 and x such that x belongs to R and x greater than or equal to 3 on the real number line. Okay, here we have the non-strict inequalities, less than or equal to, greater than and equal to, which means we can use the darkened circle in this case. Okay, first draw our number line. This is a real number line with points 0, 1, 2, 3, 4, 5, 6, 7, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Okay, find the point 3 on the real number line. Here we have 3, darkened circle or the hollow circle. Yes, we have to use the darkened circle, which means when you darken this, it means this point 3 is included. Okay, any value of x that is equal to 3 or less than 3. Less than 3 means any point on this number line which is less than 3 up to negative infinity, we can extend this. Got it? This is how you represent x belongs to real numbers and x less than or equal to 3. Less than or equal to. Okay. Now the next one, x such that x belongs to R and x greater than or equal to 3. Draw the real number line first. Extend to positive and negative infinity. Mark points 0, 1, 2, 3, 4, 5, 6, 7, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Okay, find the point 3. Here we have 3. X greater than or equal to 3, which means 3 is included. Darken this point. Darken the circle. So, this is a closed circle or darkened circle. Then, x greater than 3. X greater than 3 means towards positive infinity. Towards a positive infinity. Any point of x that is greater than 3 or equal to 3. Clear? How to represent inequalities in case if there are two inequalities on a single number line. First, let's draw a number line here. We have x such that x belongs to R and minus 3 less than x less than or equal to 3. Okay, how to represent this on the real number line? Mark points 0, 1, 2, 3, 4, 5, 6, 7, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Okay. Now, take the first part, that is minus 3 less than x. Okay. Which means x is greater than minus 3. X is greater than minus 3. Find the point minus 3 on the number line. Here we have minus 3. This is a strict inequality, which means we have to use the hollow circle. The point minus 3 is not included. Use the hollow circle here. And the value of x is greater than minus 3. Okay. These values comes under this. X greater than minus 3. Now, check the second condition, that is x less than or equal to 3. We have to find the point 3. Here we have 3. Yes. Hollow circle or darkened circle. Here it is a non-strict inequality, which means this point is also included. 3 is included. And the values of x, that is less than or equal to 3, which means towards this direction. Okay. X should be greater than minus 3, less than or equal to 3, which means this is our solution region. Yes. This is our solution region where x is greater than minus 3 and x less than or equal to 3. Very easy, right? To represent these on the number line. Okay. Now, let's do the second one. X such that x belongs to real numbers and minus 3 less than or equal to x less than 3. Draw a real number line. Extend to positive and negative infinity. Mark points 0, 1, 2, 3, 4, 5, 6, 7, minus 1, minus 2, minus 3, minus 4, minus 5. Now take the first condition, that is minus 3 less than or equal to x, which means x is greater than or equal to minus 3. Find the point minus 3 on the number line. Here we have minus 3. Now, hollow circle or darkened circle, this point is included. This is a non-strict inequality. Minus 3 is included. We have to darken this part. Darken this circle. Then any values of x that is greater than minus 3. These part. Okay. Now the second condition. X less than 3. X less than 3. Find positive 3. Here we have positive 3. 3 should not be. Here we have positive 3. 3 should not be included. Therefore, use a hollow circle. Okay. Values of x less than 3. This part. Okay. Here we have values of x less than 3. Okay. Now check both the condition. X greater than or equal to minus 3. This part. X less than 3. This part. Okay. This is the solution region. Okay. This is our solution region. Clear? Now we have a basic idea how to represent solutions of inequations on a number line. We'll do more examples and problems to make our concept clear. Here is a first example. Given that x belongs to R, solve the following inequality and graph the solution on the number line. The inequation given is minus 1 less than or equal to 3 plus 4x less than 23. How to solve this? We have to separately take both the parts. That is, this is our first part and this is our second part. Minus 1 less than or equal to 3 plus 4x. You know to solve this? We have did many problems in our previous class. We can easily solve this. Minus 1, taking this 3 to the opposite side. It becomes minus 3 less than or equal to 4x. Minus 1 minus 3 minus 4 less than or equal to 4x. In the next step, we will be dividing with 4. Minus 4 by 4 less than or equal to 4x by 4. Here, the sign remains the same because we have divided with a positive number. When you divide with a negative number, inequality reverses. You will be getting minus 1 less than or equal to x. We got the first part. Now the second part. In the second part, we have 3 plus 4x less than 23. Okay. 4x, keep it as it is here. Then bring the 3 to the opposite side. 23 minus 3 plus 3 becomes minus 3. 23 minus 3, that is 4x less than 23 minus 3 is 20. Now dividing on both sides with 4. 4x by 4 less than 20 by 4, which means x less than 5. Okay. We got the two inequalities. The first one is minus 1 less than or equal to x. And the second one, x less than 5. We can combine this. Okay. That is minus 1 less than or equal to x less than 5. That is, value of x is less than 5, greater than or equal to minus 1. Let us now represent this on a number line. While drawing a number line, we know we have to extend on both sides to infinity, minus infinity and plus infinity. To extend this, we use arrow marks. Okay, we'll draw our number line. Let's draw the number line. Extending on both sides. We'll take 0, 1, 2, 3, 4, 5. Negative 1, negative 2. Now, the first condition, that is, value of x is greater than or equal to minus 1. We have to find where minus 1 comes on the number line. Here we have minus 1. Now look at the inequality, less than or equal to. This is not a strict inequality. Therefore, we have to use the darkened circle. Darkened circle is used, which means minus 1 is equal to x is also possible. Either x is greater than minus 1 or equal to minus 1. Minus 1 is included. That's why we use this darkened circle. Now the second condition. The value of x is less than 5. We have to find 5 on the number line. Here we have 5. Inequality is strictly unequal. Okay. Therefore, we have to use hollow circle. Now, the range is represented by darkening this values. Okay. From minus 1 to 5. Remember, minus 1 is included. That is why we have darkened the circle. Darkened circle is used. 5 is not included. So, we use the hollow circle. And to mark the points or the solution set, we darken this line. Okay. All these values are included in the solution set. Clear? That is minus 1 less than or equal to x less than 5. Okay. This is how we represent it on the number line. Example 2. List the solution set of 50 minus 3 into 2x minus 5 less than 25 given that x belongs to W. W means set of whole numbers. Also represent the solution set obtained on a number line. Here the inequation is 50 minus 3 into 2x minus 5 less than 25. Okay. Removing brackets and multiplying, we get 50 minus 3 into 2x is 6x. Minus 3 into minus 5, that is plus 15. Plus 15 less than 25. Okay. Here we have 50 and 15, that becomes 65. Minus 6x less than 25. Taking the 65 to the opposite side, we get minus 6x less than 25 minus 65. Okay. Minus 6x less than 25 minus 65 is minus 40. Now, we are going to divide both the sides with minus 6. Dividing by minus 6, we will be getting minus 6x divided by minus 6 here. Minus 40 by minus 6 here. Now, what about this sign? Inequality reverses. That is, here we have less than, it becomes greater than. Greater than. Okay. Minus and minus cancel. 6 cancel. Then we have x greater than. Negative cancel. 40 divided by 6. That is equal to 6 4 by 6 or x greater than 6 2 by 3. Okay. The value of x is greater than 6 2 by 3. 6 2 by 3. Any number of x that is greater than 6 2 by 3. But there is another condition, which is x should be a whole number. 6 2 by 3 is not a whole number. 6 2 by 3 is equal to 2 by 3. 2 by 3 is a fraction. Okay. 2 by 3 fraction, it will be equal to 6 plus 0.666. Okay. 666. It goes on. That is 6.6667. Okay. Now, this is not a whole number. The very next whole number. We have to start with the very next whole number. Very next whole number is 7. 7 is included. Then 8, any whole numbers that is greater than this. Okay. 7, 8, 9, 10, etc. is the required solution set. Okay. This is a required solution set. Now, we can represent this on the real number line. Draw a number line. Mark points 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, minus 1, minus 2, minus 3. Just mark these points, that is 7, 8, 9, etc. That is, mark the point 7, 8, 9, etc. Okay. This is how we can represent the inequations on the whole numbers, on the real number line. Clear? We'll be solving problems from exercise 4B. Question number 3 of exercise 4B. For the following inequation, graph the solution set on the real number line. The first inequation given is minus 4 less than or equal to 3x minus 1 less than 8. And the second inequation is x minus 1 less than 3 minus x less than or equal to 5. Let's take the first part. You know how to represent the solution set on the number line. Here the first one, minus 4 less than or equal to 3x minus 1 less than 8. Two inequalities are there, less than or equal to and less than. Take the first part, minus 4 less than or equal to 3x minus 1. Minus 1 is taken to the opposite side. Minus 4 plus 1 less than or equal to 3x. Minus 4 plus 1 minus 3 less than or equal to 3x. Next step, we have to divide with 3. Minus 3 by 3 less than or equal to 3x by 3. Clear? We'll be getting minus 1 less than or equal to x. This is the first condition. Now the second part. 3x minus 1 less than 8. 3x minus 1 less than 8. Taking minus 1 to the opposite side. 3x less than 8 plus 1. 3x less than. What is 8 plus 1? 9. Correct. 9. Then x is less than 9 by 3. 9 by 3 will be getting 3. Now what is the inequation? We got the two conditions of inequality. We'll be having minus 1 less than or equal to x less than 3. Okay. Here, the solution set. Let's write the solution set. Solution set is equal to x such that x belongs to real numbers and the condition we obtained, that is minus 1 less than or equal to x less than 3. Okay. Now, let's represent the solution on a real number line. Draw a number line, extend on both sides to infinity. Mark the points 0, 1, 2, 3, 4, 5. Here minus 1, minus 2, minus 3, minus 4, minus 5. Now, the first part, that is minus 1 less than or equal to x, which means the value of x should either be equal to minus 1 or greater than minus 1. Find the point minus 1. Here we have minus 1. Which circle to use? Darkened one or hollow one? Yes, we will be using the darkened circle because minus 1 is included. Minus 1 is included. Now, second part, x less than 3. The value of x should be less than 3, not x less than or equal to 3. Find 3. We have 3 here. We will be drawing a hollow circle. Why hollow circle? Because the value of x is less than 3. X is not equal to 3. Now darken this part. This is the solution region. Okay. This is the graph of the solution set. Got the answer? Now let's do the second part. Second inequation is x minus 1 less than 3 minus x less than or equal to 5. Take the first part, x minus 1 less than 3 minus x. Shifting minus x to the LHS. X plus x less than 3 plus 1. X plus x is 2x. 2x less than 3 plus 1, 4. X less than, dividing on both sides with 2, you will be getting 2. The value of x is less than 2. Got the first condition? Now take the second part. 3 minus x less than or equal to 5. Which means minus x less than or equal to, shifting plus 3 to the opposite side, it becomes minus 3. 5 minus 3. Minus x less than or equal to 2. 5 minus 3 is 2. Dividing on both sides with minus 1. You will be getting x 2 by minus 1. What about the inequality? Here we are dividing with minus 1, which means a negative number. The inequality should reverse. Less than or equal to becomes greater than or equal to. That is x greater than or equal to 2 by minus 1 minus 2. This is our second condition. Okay. From this we can write the value of x is less than 2, greater than or equal to minus 2. This is our condition of inequality. Now, let's write the solution set. Solution set is equal to x such that x belongs to real numbers and the condition we obtained, that is minus 2 less than or equal to x less than 2. So, we can easily represent this on the number line. Draw a number line. Take points 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5. The first condition, that is minus 2 less than or equal to x, which means here we have to use the darken. Find the point minus 2. We have minus 2 here. Using the darkened circle because it is less than or equal to. Now the second one, that is x less than 2. Find 2 on the number line. Here we have the 2. Hollow circle or the darkened circle? Correct. We use the hollow circle. Why? Because here we have a strict inequality. Now this is the representation of solution set graphically. Join this. All these points are included. Minus 2 is also included. Plus 2 is not included. This is the representation on the number line of second inequality. Clear? Let's move on to the next question. Problem number 2. Question number 7 of exercise 4B. Find the range of values of x which satisfies minus 2, 2 by 3 less than or equal to x plus 1 by 3 less than 3, 1 by 3. For every x belongs to R, graph these values of x on the number line. First, we need to solve the inequation. We have minus 2, 2 by 3 less than or equal to x plus 1 by 3 less than 3, 1 by 3. Okay. Here we have mixed fractions. We need to change this mixed fractions first. Minus 2, 2 by 3. How can you write 2, 2 by 3? Into improper fraction. 2 into 3, 6. 6 plus 2, 8. That is 8 by 3. Less than or equal to x plus 1 by 3 less than 3, 1 by 3. 3 into 3, 9. 9 plus 1, 10. 10 by 3. The denominator is same. Now take the first part. Minus 8 by 3 less than or equal to x plus 1 by 3. Taking 1 by 3 to the opposite side. Minus 8 by 3 minus 1 by 3 less than or equal to x. Correct? Okay. Taking the LCM, 3 minus 8 minus 1 less than or equal to x. That is minus 9 by 3 less than or equal to x. Minus 9 by 3 is minus 3. Minus 3 less than or equal to x. This is our first condition of inequality. Now the second part, x plus 1 by 3 less than 10 by 3. Shifting 1 by 3 to the RHS, x less than 10 by 3 minus 1 by 3. X less than, taking LCM, in the numerator you will be having 10 minus 1. That is x less than 9 by 3 or x less than 9 by 3 is 3. This is our second condition of inequality. Combining them, you will be getting minus 3 less than or equal to x less than 3. Okay. Let us represent this on the number line. Now, if we are writing the solution set, we will be having here x belongs to R is the replacement set. And the solution set is equal to x such that x belongs to R and minus 3 less than or equal to x less than 3. Here we have put the values 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5. Now we have to mark the points. Okay. First part, that is minus 3 less than or equal to x, which means minus 3 is included. The darkened circle. Second, x less than 3. Find 3 on the number line, put a hollow circle because 3 is not included. Now draw a line here, joining them. This is the representation of solution set graphically. Clear? Here 3 is not included and minus 3 is included. All other values of x that lies between minus 3 and plus 3 are also included. All the real number values. Clear? Let's move on to the next problem. Okay. Problem number 3. Question number 10 of exercise 4B. If 5x minus 3 less than or equal to 5 plus 3x less than or equal to 4x plus 2, express it as a less than or equal to x less than or equal to b, and then state the values of a and b. We need to find the value of a and b. To get in this form, we just need to solve the given inequation. Take the first part, that is 5x minus 3 less than or equal to 5 plus 3x. Okay. Next, what to do? As usual, bring 3x to the opposite side. Plus 3x becomes minus 3x. That is 5x minus 3x less than or equal to 5 plus 3. Minus 3 taken to the RHS. 5x minus 3x is 2x. Less than or equal to 5 plus 3 is 8. X less than or equal to, dividing on both sides with 2, you will be getting 8 by 2 is 4. So this is our first condition of inequality. Now the second part, 5 plus 3x less than or equal to 4x plus 2. Now you are experts in solving these inequations, right? I know you all have solved it. 3x minus 4x, taking 4x to the LHS, less than or equal to 2 minus 5. 3x minus 4x is minus x less than or equal to 2 minus 5. minus 3. To remove negative, we can multiply or divide with minus 1. When I divide on both sides with minus 1, I should reverse the inequality as well. That is minus x by minus 1 greater than or equal to minus 3 by minus 1. That is x greater than or equal to plus 3. This is the second condition of inequality. Okay. Now let's combine this. We have 3 less than or equal to x. X greater than or equal to 3 means 3 less than or equal to x. And the second part, x less than or equal to 4. Less than or equal to 4. This is the inequation, required inequation. Now just compare with this one. A less than or equal to x less than or equal to b. Same, right? The value of a is equal to, at the position of a, here we have 3. In the position of b, we have 4. Therefore, a is equal to 3 and b is equal to 4. Clear? Very easy question. We didn't want to draw the number line or anything like that. Just solving the inequation, we obtain the inequation. It is expressed in the form a less than or equal to x less than or equal to b, from which we determine the value of a and b. A is equal to 3 and b is equal to 4. Got the idea? Let's move on to the next question. Here is our last problem for today. This question is somewhat similar to the word problems we have studied during the linear equations in one variables and linear equations in two variables. Let's see. Question number 28 of exercise 4b. Find 3 consecutive largest positive integers such that sum of 1/3 of first, 1/4 of second and 1/5 of third is at most 20. What does at most means? Maximum 20. It cannot go above 20. Okay. Now, let's take the consecutive integers. Let the integers be x, x plus 1 and x plus 2. Why x, x plus 1 and x plus 2? What does consecutive mean? Consecutive means the very next. If you have taken x, x plus 1 is the very next integer. X plus 2 is the next integer to x plus 1. Okay, we have taken the 3 integers x, x plus 1 and x plus 2. Now it is given that the sum of 1/3 of first. How do we represent 1/3 of first? The first integer is x. 1 by 3 x. 1/3 of x. 1/4 of second. 1/4 of second. 1 by 4 of second integer is x plus 1. X plus 1. And 1/5 of third. Third integer is x plus 2. X plus 2. We need to take 1/5 of x plus 2. When we take the sum of this, we'll be getting at most 20. At most 20 means, as I said, the maximum value can be 20. It cannot go above 20. That is less than or equal to. The value obtained can be less than 20 or equal to 20, not greater than 20. Okay. Now let's solve this part. X by 3 plus x plus 1 by 4 plus x plus 2 by 5 less than or equal to 20. Taking the LCM, 3, 4 and 5. You will be getting 60. Hope you all know to take LCM. Now, 3 into 20 is 60. You will be getting 20x plus 4 into 15 is 60. That is 15x plus 15 plus 5 into 12 is 60. That is 12x plus, here we have a 2. That is 2 into 12. 2 into 12, 24. Less than or equal to 20. Now shifting the 60 to the opposite side and adding them. That is, we have 20x, 15x and 12x. 20x plus 15x is 35x. 35x plus 12x, you will be getting 47x. Plus, we have 15 and 24 as constants. 24 plus 15 is equal to 39. Less than or equal to 20 into 60. Okay. That is 47x plus 39 less than or equal to, what is 20 into 60? 1200. Correct. 1200. Now taking 39, positive 39 to RHS, it becomes minus 39. 47x less than or equal to 1200 minus 39. 47x less than or equal to 1200 minus 39 is 1161. Okay. Now we can write x less than or equal to, dividing on both sides with 47. You will be getting 1161 divided by 47. Okay. On dividing, x less than or equal to 24.702. When you divide this, you will be getting 24.702. That is, the value of x should be less than or equal to 24.702. Here it is given that consecutive largest positive integers. We need integer values. 24.702 is a decimal. It is not an integer. We cannot include 24.702. Now the largest integer, that will be less than 24.702, which is 24. Clear? 24 is the value of x. If x is equal to 24, then what is x plus 1? X plus 1 is equal to 24 plus 1. That is 25. X plus 2, 24 plus 2, 26. The consecutive integers are 24, 25 and 26. Clear? These are the consecutive integers. Hope you understood this question, how we solved it. The word at most means the maximum value. Even 20 can be included but not greater than 20. With this, we solved the problem, solved the inequality and got the value of x. Clear? That's all for today. In today's class, we have studied how to represent the solution set on a real number line and solve more questions from exercise 4B. There are a few more questions which you can solve on your own. I'll be back in the next session with a new chapter. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.